small t1 equals to small x1 this, and the value of this equals to probability of bracket x t n plus 1 equals to small x n plus 1 upon x t n equals to small x n. So this is the property of Markov process, where t1 is less than t2, t2 is less than t3, it goes until tn plus 1, tn plus 1. Similarly, xi is the ith discrete state space value. So now I am explaining about this particular property, which is defined as pxtn plus 1 equals to xn plus 1 upon xtn equals to xn, comma xtn minus 1 equals to small xn minus 1 to xt1 equals to x1, always be equals to probability of xtn plus 1 equals to xn plus 1 upon xtn equals to xn, where t1 t2 t3 and the duration timing is till tn plus 1. Now xi is the ith discrete state space value. So this particular x is the representing the space value. What is the value of quantities? That is the space value, and this is the particular time, at which time. Now, so we can explain this particular property. It states that, so as per the Markov process, it states that the probability, p representing the probability that the random variable capital X, here X is the random variable, takes on the value xn plus 1, space value as value, or can say the space value. So the probability of it says that the probability that the random variable x takes on the value xn plus 1 at time step and n plus 1, n plus 1 is the time step. During this particular time step, the particular random variable capital X takes on the value xn plus 1 is entirely determined by its state values in the previous step n. So I am again repeating. It states that the probability that random variable capital X takes on the value xn plus 1 at time step n plus 1 is entirely determined by its state value in the previous step small n, and it is independent of its step values in n earlier time steps n minus 1 comma n minus 2 comma n minus 3. So basically this is the particular Markov process property which is defined here. Next thing is that, so there are 3 points. First point is that the particular probability of the random variable x takes on the value xn plus 1 at time step n plus 1 is entirely determined by this term or its state value in time step small n. This is our first point. Second point is that we may the previous we may also state that the entire past history of the process, it means whatever going on in particular steps n minus 1 n minus 2 n minus 3 that etc, whatever the values in time step n minus 1 n minus 2 n minus 3, all the particular values summarized in the current value, it means x t n have entire past history of the process. So in so past entire past history of the process is summarized in its current state. Hence, always be next state is determined only by current state. For finding the value of xtn plus 1, we go for xtn, not for xtn minus 1, xtn minus 2, because xtn is the summarized value of all past values or earlier values. Similarly, the next state we can find out by its present state. So this is the main property of a Markov process. Or we can also say that the time period for which the process has process as stays in the current state should play no role in determining the next state. So the particular determining for determining the next state value, we don't require that particular the particular time period or duration for which the process stays in current state. So it is independent of duration of transition from one state to another or the duration of staying in a particular state. So this is our Markov process. Now we will discuss about the most important, very important topic, that is birth death process. It is most important topic, birth death process. So basically, before studying BT process, we will understand the population. Basically, generally in our locality or in our city, in our town, the number of people living. So that particular different types of activities are going on in our environment, in our locality. So basically, this birth death process is related to that particular population process. So basically, in telecommunication, there are three things. First thing is a call arrive, or we can say that whenever a particular subscriber attempt a particular call or call attempt, it is similar to birth in a population. Second thing, whenever a call is terminated, it is related to death. And whenever no birth, no death occur, it means there is no change in population. So in birth death process, if we apply, so as per technical point of view, if we discussing about birth death process, then if we apply the restrictions that the state transition of a Markov chain can occur only to adjacent state, then we obtain what are known as birth death process. As per this particular definition, we can say that in Markov process, which we already discussed earlier, in Markov process, if we apply a restriction, the restriction is that if suppose a particular Markov process, if any particular in as per we applying a particular restriction in a Markov process or Markov chain, that the Markov chain can occur only to adjacent state. It means if suppose the random variable have value at time n plus 1, then it is a particular fixed state. It means it can be moved either to x t n, or it can move to x t n plus 2. It means if suppose there is a state 1, then it is go to 0, or it will go to 2. It can't go 1 to 3. So this is the particular process is known as birth death process. So if we apply the restriction that the state transition of Markov chain can occur only to adjacent state, then we obtain what are known as birth death process, which can also represented as B dash T process in short form. So it is customary to talk of population in a BD process. Let let k is the k is a random variable which is the number in population. That means k is a random variable which k is a random variable and k is the number of population which represent the state value of the process. It means suppose it means we can assume let k is the number in population. So k is also known as state value. So generally we can say that k is a state which defined by number in total number in population.